thank everybody for the kind reception we received while we were down in Australia a few weeks ago for RIMPA. For those of you I met, thank you very much. It was great. So I thought I'd actually, as I do a quick introduction of myself here, ask. So that was my first time actually in Australia, and I obviously made it to the Gold Coast, Sydney, and actually went to Wollongong. I'm kind of curious for the group of people that we have here today, how many of you have visited a city in the US? And if you have, what's your favorite city? And if you just put that in the chat, then I'll judge whether or not that's a good place or not. Um, I'm Archives 360's Associate General Counsel and VP of Compliance. I have worked extensively and worked a lot across highly regulated companies, in particular in financial services, a little bit in pharma and energy as well, but always focused on how do you deal with petabyte scale, huge complex environments for compliance, for surveillance, for investigations, and all those things and things that we now live with on a daily basis. So with that, I wanted to provide, as part of this kind of three webinar series. The first one is a little bit of a setup here, like what's driving the need? What are the things that we need to think about from a driver's perspective and some of the frameworks? And then as we get into these other series, we're going to get a bit more and more prescriptive. By the way, I'm in New York for right now for those, for Lynette. I'm actually sitting in a hotel room um, outside of New York. All right, so I'm going to go ahead and get started. And just by way of a quick agenda, talk a little bit about how the past is providing some prologue, what the future of data looks like, common approaches, and sets of obligations. We have to obviously talk about AI, ML, and robots, and then finally what we think about from an integrated data governance perspective. And I've also incorporated a few use cases and case studies that I think provide really good examples of the challenges people are facing and how they're trying to at least solve a portion of those challenges. So if in the future we're sitting here and we're trying to celebrate the AI overlord's birthday, we're probably going to be celebrating the year of 2003 because that's the year the world economy started producing more transistors at lower cost than grains of rice. Transistors, the building blocks of chips, those are the things that actually do the logic, the zeros and ones. That's where this all happens. And it's really now been 20 years since our world produces these transistors on these chips of enormous density, and do so cheaper than rice. And it's really hard to think about and get your head around. But that's where we are. And this drives an enormous amount of capability and compute. And it also takes what was something that was done on big chips and it's putting tremendous capabilities on small chips, which goes into all the different devices and all of the different things now that drive things like AI and ML. And so we're at a point now where actually, so when you make a chip, basically it's made kind of like silk screening, but instead of a screen and ink, we when you produce these, they're actually done using light and masks and filters and lenses. And so what's happened though is the wavelength of light that we see, of visible light, is actually too big. And we're now using extreme ultraviolet light. And I'm just using this as a point to show you that we're creating these extraordinarily dense, compute capable chips that go into everything, and this is going to continue. As a matter of fact, they'll get to the point where they're going to start using soft X-rays probably because even ultraviolet won't be small enough. So what is this actually driving? Like, what's the practical implication of what I've just articulated? Well, this is one practical implication. We've kind of reached this point where the capabilities in these chips now are such that we can run extremely complex models against huge volumes of data. And this is, as source Microsoft here, this is just showing you the adoption rate um, to go to 100 million users. And you can see, mobile phones took 16 years, the internet 7, Facebook, if you like that kind of thing, 4.5. ChatGPT went to 100 million users in 3 months. That's extraordinary, right? And that's just one, obviously, and it's the most visible and probably the most popular model right now for AI. But it gives you a sense for the rapid pace of AI adoption. And obviously, AI is going to drive all kinds of other things for us downstream. This is another thing to spend a little time with. So when we think about data and AI, you have to think of it from an impact perspective, both from a total dollars, but also as a functional spend within organizations. Because what this is actually showing us is where this data and where the information is that we're going to have to manage and put into various platforms to govern and maintain, where it's going to originate and what the drivers are behind it. So this is McKinsey's study, and they're looking at those two vectors, the impact from a functional spend perspective and then the impact from total dollars. And if you look up and to the right over here, the two primary areas that you see up here that have both a high impact from a total dollars perspective, but also functionally, is in software engineering for corporate IT and for product development. Well, what does that mean? Well, especially from a product development perspective, that means that the cycle time necessary to produce a new product, to bring new capabilities to organizations, both internally and externally, in product or in corporate IT, that means that those those applications are just going to continue to create, consume, and move information that much faster at that much more volume, right? So you get this velocity and volume of information that's going to continue to increase simply because product development and corporate IT can actually create products and infrastructure faster to actually create and consume and move more data. So you get in this little bit of a feedback loop where this will just continue to be like a flywheel, constantly creating and increasing the volume and velocity of data. The other area that's interesting is this area of customer operations. And so this area you can think about a lot. This is probably the easiest area for us to kind of think about how AI gets applied. And it's in chatbots, or it's in this interactions, in these customer interactions where they can go and they can ask questions of ChatGPT, or that you'll see obviously all these different co-pilots and these different solutions out there where you're going to be just issuing prompts and questions to a system, an AI-driven system that is going to be interacting as if there might be a person on the other end, or there might have been, some set of research or something else on the other side of that. So now we're creating all kinds of new collaboration and interactions, some of which are subject to all kinds of regulatory and compliance obligations. This isn't just, hey, I want to use some sort of chat interface to change a flight or to buy a new book. These are interactions that are happening with financial services organizations, through healthcare organizations, with the government. All of those interactions, all of a sudden, that may have occurred on a phone, may have occurred maybe through a website, but all of these highly interactive conversations are now happening. And those things, again, are happening in spaces and in industries where you actually have sometimes an affirmative obligation to capture that information, or there's discussions of somebody's financial or health or whatever it is that then present all kinds of risk and all kinds of security and privacy concerns. So the focus of these areas here I've highlighted is this is going to create, again, a huge volume and velocity of data, but create all kinds of new um, risk and obligations associated with the kinds of interactions this generates. Now, finally, perhaps there's a little bit of good hope here. At least I'm trying to pull some good hope out, in the sense that this is obviously going to be tremendous value and benefit to organizations, but create new risk. Um, McKinsey thinks that there's a real opportunity also from a legal and a risk and a compliance perspective, to help and use AI to actually increase the capabilities in these functions as well. So let's talk then a little bit about the modern data landscape and what this is going to start to do. This is one view. Actually, I have another one that actually has a slightly different growth forecast on this, but this is really representative, right? So you'll continue to see rapid growth of unstructured and structured data, but unstructured data, at least in IDC's forecast here, is scheduled to increase about 2 times the rate at which structured data does. And that makes a lot of sense. If you think about many of the generative AI use cases, they're really generating unstructured forms of data. Sure, you can output, you can get some spreadsheets, or you can output, data. You can get source code generated by AI, but most of this is actually creating unstructured forms of data. Now, the one thing is that on the structured data side, it's not so much the volume of data in these things; it's actually the data and the complexity of the applications as they age. And that's where the volume is less important than this complexity. And I think if you look at most organizations that had these, until really the last few years, so many organizations had huge workloads on premise, or large workloads that were in silos, or applications that are no longer maintained well. That creates its own complexity and its own risk that needs to be managed, even if you don't get the same volume. The other thing is that the analytics and technology that's out there today is going to blur the distinction between what we think of as structured or unstructured data. And I would just urge everybody on the call, and I'll show you another slide here in a minute, but I would urge everybody not to even worry about getting into um, metaphysical conversations over, is this structured data? Is it unstructured data? Is this information? Is it data? Is it data? Is it content? It's all going to blur together. It's all data from our perspective, and that's really kind of how things are going to evolve. The systems and capabilities and so much of what you're seeing today um, means that you can consume and create structured or unstructured data in the same platforms. This is again kind of sourced to Microsoft here, although they actually have the sources down here to IDC as well. Just gives you a sense, right? I mean, they're talking about they get 2 billion documents a day into M365. IDC says globally people are spending $60 billion on storage and managing content. That's real money. I suspect that number is probably higher, but that's one of the best numbers that we have. And then IDC in this form, and I think it's just the cut of the data that they're taking, but they're saying 80 to 90% of the data growth will be associated with unstructured data. And I think the way they're viewing this is the split between structured and unstructured, as opposed to the CAGR, and that's what that data represents. But again, if you go back here, you can see that the overwhelming majority of the data that we're talking about here is represented by unstructured content. So we put together this slide to try and explain. So we talk about unified data, right? Unified data governance, and that's kind of our mantra. Um, and we do so because we're trying to deal with, again, a range of types of data or content or information that organizations actually deal with. And so, starting from left to right, you kind of move from the most unstructured to the structured as we think about it. And obviously e-coms, electronic communications is a big source of data for enterprises, and not just email, of course, but all the different kinds of collaboration systems and chat, text, and everything else. Then we have our typical files, unstructured files that we think of, right? So these are the standalone PDFs and Word documents and other files, invoices, whatever it might be. They're generated and they're individual files, and the information that resides within them is really what describes what that object is or what that document is. We start to get into use cases, and I'll show you some in the case studies later, where you have large sets of metadata associated with a document. So think of this as like a transaction that has an associated document. So a trade that has an associated trade confirmation. Maybe it's an employment agreement associated with a transactional record of when somebody started in an HR system. And you have those two sets of transactions or pieces of metadata, and then the associated object. We get into these situations now where a lot of people are also looking at trying to get this data out of systems that are legacy, and I'll go through that as well. And you'll see often all kinds of data coming out in flat files in some form. And these are denormalized. Typically, they could be in any form. These could be anything from a CSV file to some sort of Parquet file or some, think of these almost as like a large Excel file that have been flattened out from different exports. And so that's another thing, again, where the data is represented within a set of files, sorry, within a file, and really is a set of rows and columns that have been denormalized out of some other system typically. And then finally, you get into more complex structured systems where you have more complexity around, many different tables, many different associations and joins within tables in order to generate a transaction or a record. The record is really some combination of many different attributes and elements of many different tables across this application or this database. And then you get into the ERP situations as well. And so the point of this slide is to try and say, look, the world is not structured, the world is not unstructured. The world is kind of in this continuum, and that's okay. And it's actually good because, like I said before, the systems now are out there that are starting to create, consume, and analyze data across this range. So the governance platforms and the records platforms that we put in place also have to have the ability to deal with this complexity as well. And we can't assume that the data is going to be nicely structured or unstructured. The only other point here I'm going to mention is that the focus around the ability to both extract and leverage metadata is really key when you get to the scales that we're talking about. And we have customers kind of in this bucket here and in this bucket here, or these two buckets, and they have petabytes worth of data. And you can certainly index all that data from a full content perspective if you want. You probably will spend a fortune to do it. And you'll find that the majority of times, many times, you don't need to do that if you can get sufficient metadata from the systems, the source systems. The source systems maintain sufficient metadata, or you can find a way to extract or get that metadata out of those objects. That's the way you scale into petabytes and do so with a lot of ability to perform analytics and analysis against what you're working with. So for us, again, it's our thoughts on this is really, it's all just data, right? And it's about associating the obligations that map back to that data, right? So there's a set of affirmative obligations that are the traditional drivers of governance. There's risk, of course, now around things like privacy and security that go along with it as well. And when you get into the volume and the complexity of both the data that we're working with, the velocity and the volume of it, but then the volume and complexity of legal and security and privacy requirements, you start to realize that these obligations are also overlapping across this information. So the next thing to think about is if AI is a driver, which it is, and AI is a driver to pushing a lot of this data out and creating it from the outset, there are going to be points at which AI can be part of the solution as well, and it will need to be. And AI and technology are the only ways we're going to deal with some of the stuff at the scales that we have to deal with. So one way to think about this is look at the data and the obligations, right? So take any piece or any set of data, whether it's a one record or any sets of records, it has a number of obligations that are typically associated with it. It doesn't just have a retention or disposition obligation. It's got to have some sort of security typically around it, often privacy, there's data sovereignty, other compliance requirements. We have to have the ability to actually take this data or elements of the data about what we're storing and managing and governing, and we have to be able to analyze it and actually understand that over the long term, how that information is actually going to need to be retained, stored, disposed of, whatever it might be. You still need to retain the ability for access to operations, even if you get these objects or this data into environments that are really designed for longer term retention. You still have to sometimes be able to pull that data back in a way that um, not necessarily mimics, but certainly provides the ability to look at things through an operational lens. And I'll give you an example here. So, if you think about something from an HR perspective and looking at it from an employee records perspective, and this is actually coming up quite a bit because people right now are trying to retire out some of these old HR systems that they have, right? So if you and here in the U.S. in particular and elsewhere, we're also a very litigious society. So it's not infrequent that um, whether it's a regulator or whether it's a private litigant, it comes into an organization and says, "Hey, look, I need to understand the pay history for an employee or a set of employees. I need to see their background checks. I need to then see their performance history, right?" And so that's coming and asking, and that might be for something that happened 5 or 10 years ago. Right now, that data is either sitting maybe somewhere else, or it might still be in the operational system, but who knows? But you have to have a look at that data for an almost from an operational view, even though it's coming from a legal and an e-discovery context. It almost has to kind of be viewed in the way of, hey, how did that actually look from an operational perspective as well? So that was just one example. And then obviously legal and e-discovery. What I'm trying to drive here though is you have to view data or data sets or records or whatever we want to call these things across all of these different obligations. And you have to put practices and platforms in place that can help you achieve many of these in a common framework as opposed to having silos dealing with each one of these. All right, so what does this mean? Well, so this is where we start to think about um, how do we then map what I just showed you before also to a concept of value and risk. So information value decays over time, right? The easy example is a design for an iPhone 1 has a lot less intrinsic value than the design for the upcoming iPhone, next year, whatever it's going to be, the 16. And that's true for most information. Now, it's not that the information becomes valueless. There's often, and now with the capabilities that we have in analytics suites and in AI, we have an enormous ability to tease out even the most subtle insight from value, and do so at scale. But what we have to think about is risk actually increases with information over time, and it does that for a few reasons. One, a lot of the data that sits in information over time in systems over time sits in systems that are not well maintained as they age. They don't have the same ability to security patch. They don't run the same OSs. They can't be upgraded. They aren't adapted to using the latest cloud technologies, whatever it might be. A lot of people still have access to it. The authentication systems aren't tied in as tightly as they used to be. And and you see that risk will increase over time with information if it's left in places and operational systems where it doesn't really need to be at some point. So I don't know exactly with each system and each record and each information type, but there is a point at which the risk starts to outweigh the value of that information. And that's at a point where we start talking about retiring data. There's Yeah, I've been doing this long enough that the manage in place story, and I can still remember in '08 having this discussion in technologies and in practice. The manage in place story is one that we have had now for 15 years. But the manage in place story had one common theme, and that is that operational systems are not designed to handle information at scale over the long term. And I know that there's a movement right now, again, in managed in place, sometimes driven by, the providers of those technologies where the data is created and consumed and shared most often. Um, but what you'll see is those operational systems are just not designed to handle it over time for the same reasons I've just articulated. And they'll grow, and too many people have access to it. And my point here is really think about this value and risk model, and really think about whether or not leaving data in operational systems and governing it in those source systems over the long term makes sense. There might be places it does. I'm not saying that's it always, never going to be the case, but if that's your governance strategy, I think over the long term, you're probably going to be remiss, just like a lot of people were, even from the first iteration of it. And so here's another and I can give you any number of examples of this, but and we actually were doing some analysis for a medical company, kind of adjacent to the insurance space, and we found that when we were analyzing their older information that came from all these different acquisitions, and their current data was pretty solid. They didn't have a lot of privacy or security issues or gaps. But when we analyzed the old sets of data that were there from different acquisitions they had done from the 2012 through 2018 timeframe, it was a disaster. And they had all kinds of stuff they should never have had in places they had no idea it even existed there. So now what we start to get to is this modern capability we have in real-time analysis and AI and machine learning and advanced analytics. What we're doing now is then aggregating and correlating all kinds of sets of data that we never were able to do in any reasonable amount of time before. And so if you think about insurance companies, these are state companies in the US and in Europe. Some of these insurance companies, right, have been around for 100, 200 years. Think about Lloyd's, how long they've been around, right? So insurance companies have been around forever. Their job has been to analyze past events, predict future outcomes, define risk, give you a bill. Now they're able to do this in real time, and they're doing this by, anything from, looking at how you drive, to looking and correlating enormous amounts of personally, highly personal information from from medical carriers. And they have dozens or even hundreds of different sources and third parties where they're gathering all this information. And individually, each one of those elements or assets might not have really information assets, have created risk. But in practice, now being able to correlate it, it does. And it creates an enormous amount of risk. And the same thing is happening in your organizations potentially as well. You're bringing all of these different sets of data into what were data lakes, now we're data lake, where data lake houses, or whatever you want to call it, and whatever the frame of the day is. But all of that stuff's going into these enormous data analytics layers and correlating, creating all kinds of risk that people are still trying to really get their hands around. In parallel to this, we're at a point where the information is and the kind of information that you have, and Australia doesn't have it yet, although there is some proposals out there outside of the national security related information. It's this concept of what I call national interest, and that is that countries are defining sets of data that are of national interest to the country, that require that information reside within the four corners of that nation state. These are some examples here. Um, there are more, but these are examples. So as multinational companies, this is a challenge. Now, this will continue to grow, and I suspect that most countries will actually end up getting here. So we've gone from a point where, when the internet was first launched, we were breaking down borders. It didn't matter where you were. You could access data. You could have huge spans of control and go and acquire all kinds of companies all over the planet and manage them and all that. But because of any number of drivers, which include making sure that the privacy of its citizens are protected, that the energy grids are protected, the financial markets are protected. Any number of those things have defined now classes of data that cannot leave that country. And in some cases, actually have to be managed within and by uh, individuals who actually are, you know, resident or citizens of that country as well. This is going to continue to grow. This will continue to be pushed out. Now, the one positive thing about national interest and data sovereignty is that the cloud providers, the hyperscalers, you know, Microsoft, an Amazon, a Google at some level, they're deploying more and more into countries so that that data can reside in the data centers there, but companies don't have to set up their own data centers and maintain all of that, and not make use of modern cloud environments that have tremendous value in other places where it doesn't make sense for a Microsoft or a Google or an Amazon to deploy their infrastructure. You're seeing countries actually help fund that. Even Germany, the Sovereign Cloud Initiative has a significant government backing. You know, the Kingdom of Saudi Arabia and Dubai, they're basically, you know, funding a large part of that because they want access to those technologies for their clients. I'm sorry, for the companies and for their citizens. So what does this mean? The key elements for your roadmap around data sovereignty. This is true for a lot of things, but this is extremely important for when you think about the data sovereignty pieces that are going to be driving governance decisions. Make sure you understand the data and the workloads that go back that map to these schemes. You know, if these schemes define sets of data, sets of or classes of information, or third parties that might meet the criteria that fall under these regimes, you really have to understand where you interact with them and what kind of content and data that you have. You have to understand where the data is, obviously. It's created, disseminated geographically. Again, third party is a big part of this. Look to leverage the cloud infrastructures, and then classification is going to be really important. All of these regimes require that you have the ability to classify data, or that you understand that the sets of data or scheme, the classes of data that must reside in country are identified as such, or that you have control of it. And so that's going to be a predicate for a lot. All right, so now I want to switch and talk a little bit about machine learning and AI. You know, machine learning and AI tools are not new. And actually, many of the algorithms that are used in different AI and ML tools, the math and the algorithms themselves have been around for decades or even longer. It's really the ability to com the compute resources that are available and necessary to do this at scale that have made the difference. Now, it's important though too, because in certain jurisdictions, and certainly in this jurisdiction and some in Europe, and in a bit in Australia as well, legal and compliance solutions have been using machine learning models for over 10 years. You know, when you look at things like predictive coding and classification and technology assisted review and e-discovery, um, pardon, been around for 10 years in different forms. It's been inconsistent, but it's been out there. So we have a track record of their use, even in highly regulated or in legal context. Um, you know, AI and advanced analytics, at the end of the day, is around, you know, deriving insight from enormous sets of data. That obviously creates opportunities and risks, like we talked about before. So here's some examples of you know, where AI and ML are going to be used. I think pretty typically in a lot of organizations or in governments. You know, content classification, as I mentioned, content identification for information requests of government entities, contract construction and document construction. This is where generative AI is really going to do a tremendous amount, even already in the legal space. You know, the amount of number of solutions out there that both create and analyze contracts and develop and author content is pretty significant. We even have some um, some great case law already developing about people who've used AI and ML or generative AI to create legal content that expose what hallucinations are. And I can, if anybody wants to know what AI hallucinations are, put in the chat and I'll answer that when I'm done here. And then obviously self-service is going to be a very common use case for many people for generative AI. So what do you need to know about AI? And this gets into the governance of AI or the use of AI. Um, AI really is a combination of data and some model that yields some output. So you have to first think about, all right, well, what data am I talking about? In our context, we're always talking about data that's owned or managed by the entity, the government, the government agency that we're working with, a third party, whatever it might be. We're typically talking about that. And then what models? Are these models that we've created, or are these models that somebody else has created? And so where you see this combination of your data and your models, this provides the highest level of control. It allows you to take and train data or train the models against your data. So it's obviously going to be the best because it's like using your data and to create these models, and you have control over that. Now, the downside is you don't get the leverage, right, that somebody else has already gone through the process of creating models to whatever it is, identify and classify documents, generate content, whatever it might be. So you don't get that benefit. There's another set of models that are out there, and a number of the contract analytics firms have done this already, which is you create models based on um, basically the models are created by a third party, by the software provider or SaaS provider, whoever it is. And those models are generated with some set of data, um, and then they apply it to your data, right? So your data, their model. Now, this is good because the learning is coming from a larger source than just your own data, and you still have access. Obviously, it's still just your data. Now, the downside is it may not be as discrete as you want. And then the third one here, sharing your data to create models. This also there's pretty good extensive experience here in some of the legal and contract analytics use cases where these models are being created leveraging your data, but they're not taking the data like in a generative AI context. It's really just updating and informing the math, if you will. Non-generative AI use cases for this is a lower risk, and it's actually a reasonable risk in general. You'll see how this is done, um, as opposed to in generative AI use cases where that data might be exposed if you don't actually have this set up properly. And then finally, they're sharing your queries or your prompts to create content and models. This is where you really have to understand, and this is you get into the public kind of AI, Chat GPT kind of world. You really have to understand how these environments work, what information they might retain from what you submit, what controls can you place, and what options do you have to limit their use of your queries to inform or to basically save your queries. Now, I'll give you an example of why that matters. There's a case with a very well recognized electronics manufacturer, very high tech company, and the query and the prompts were actually a series of source code snippets that the engineering team had submitted into ChatGPT because they were trying to solve a problem that they were having in their code. Well, this actually exposed some proprietary data in how this manufacturer was actually using software for certain issues. The software which was the prompt, the code, became part of ChatGPT, became part of the corpus of data that could then generate content. So it effectively exposed their content now, and it became part of the public domain. So you really need to understand how that's all actually working.
George, we
So
just had
yeah.
one question from Kamal. He's saying, isn't there a major issue around the bias with the data being used or created with the models?
So the answer is yes. And this gets to you don't always know what the data sets are that were used to create the models. And this is where and again, it depends a little bit on the bias. So like there's the scientific and mathematical bias, right? There's a bias of, if I'm training a set of data and it's limited, I'm going to be biased, based on a number of factors mathematically. Then there's the bias that we think about more from a legal perspective, which is it going to, is the decision making going to bias, against a set of individuals or a class of people in some way, or a political opinion, or whatever it might be. And those are all possibilities. And I'll give you the third one, right, which is not so much bias, it's this hallucination concept that I mentioned before. And hallucination is basically the system is trying to generate content, and it's trying to create content for you. And it can create something that doesn't exist. And the example that we have here in the US in the legal market is a lawyer had a brief drafted by ChatGPT. The brief went to court. It included a series of citations that appeared to be very relevant to the facts of the case. And it turns out that the citations that were created were completely fictitious, completely made up, but they looked perfect. They looked just like you would expect. And it cited properly within the document, but it was literally made up. And of course, when the judge got called on that, or the judge called the lawyer on that, he's now become quite famous, and also will likely get sanctioned, if not disbarred, unlikely to get disbarred, but certainly sanctioned. That's so the answer is yes to all that. There's bias, and then you get these hallucinations as well, and that's why you have to really be careful and understand what data is being used, what models is being used, and then ultimately test and verify what's happening. Um, this is another view of something I've written on before, but it's basically, now that we understand that that same piece of information is has any number of obligations associated with, what do you do? Well, what you have to start to do is look at the technologies and the policies and controls that you can place around the data for security purposes, privacy, and legal and compliance, and see what you can leverage across all of those. So try and see about the systems and technologies you have today. Can I apply more than one set of controls against it to meet more than one of these obligations? I often tell people to think about starting with security if you can. Obviously, in legal compliance, records, compliance, and privacy as well. There's been good investments of pardon over the last few years. But you have to remember, the information security and the cybersecurity teams, they've been funded at levels appropriately, for the last 10 years that most other parts of the organizations have not. And there are good technologies in those areas for things like asset and data mapping, asset inventories, so information inventories, um, extending security and DLP controls into things, or into governance, and then obviously all the different authentication entitlements systems as well that are really necessary when you start thinking about managing the stuff over the long haul. I'm going to just briefly go through, and I'm not trying to sell you at all or anything. I'm not talking about like the solution we're providing here. I'm creating and giving you 3 case studies, but these are just live clients. These are real clients of ours. And I just want you to focus really on the challenges and a little bit of the benefits. But I wanted you to see, like, these are real things with real big companies with real challenges that probably look like yours. And this is what's driving the need, right? This is an example of, is a very large American health insurance company. You can see it serves 100 million people or more. Very typical, the kinds of challenges that we've seen: legacy systems, many different places. Their communication channels are extremely critical, both internally and externally. They have all kinds of regulatory obligations to keep this information coming from many different directions. And so, we you can see the kind of scale we're talking about here, 1.3 petabytes of data, right? But the benefits of when you start to pull this stuff together into a modern governance framework is you really start to get control of the security, of the cost, of the e-discovery, centralizing compliance. And there was no way that you were going to be able to do this scale by leaving this data in what were then multiple archives or in source systems. The collaboration systems, the comms channels are not designed to handle this scale. You cannot manage that content in place at that scale. This is a global investment bank. This is a very hardcore records retention and data governance obligate or use case. If hundreds of homegrown record archives and different systems that generate all kinds of records that are subject to retention and compliance obligations. They're producing all kinds of data out of all kinds of systems constantly in the mid office, front office, and the back office. We're talking many, many petabytes of data have to meet the SEC and CFTC requirements. This was an excellent example of where the operational systems still work just fine, but where the bank realized the operational system was not the place to try and manage these objects long term that needed to live, but for many different years, but not just many different years, but in a very compliant way. The operational systems was not the place for it. It was just bogging down the operational systems, was making their operations slow, and they developed this kind of dedicated really governance and records. Probably one of the most sophisticated we worked with on their team. Like this entire service to take information from all these different operational systems and get it into this environment so that the rest of the operations and the day-to-day business runs much faster. And then you apply all the different security entitlements and everything else that goes around it, and complex record keeping requirements across many different classes of data. And then finally, this is a national court system in another country. This is not the US. If it were, it would be spread across 50 states, and we'd still be thinking about how to do it. But similar kinds of things. They had a whole bunch of legacy systems and content systems, a ton of data. It couldn't stay in those operational systems. Some were going to die and they were going to retire anyways. The legacy systems were just too hard to manage. They have retention rate periods up to 100 years. Now, obviously, most of us are not going to be around to see any of these documents actually deleted, but we had to get them into an environment that was designed for at least long-term retention and management. And this was all kinds of content. It was everything from highly unstructured content, audio transcriptions, all kinds of stuff. Again, getting a lot of this data at these scales out of operational systems where they don't belong, getting them into a long-term data governance platform. So I'm going to wrap this up and I'll take questions. But look, at the end of the day, you got to understand what you have. Classification of data at some levels, really a predicate. Move your critical workloads and systems to modern architectures. Look for common approaches, right, to deal with many of these different obligations. See where you can lean into cloud solutions if you can, because they provide a really broad range of capabilities that are baked in by the hyperscalers or by all kinds of other people building on top of those environments. And they're investing billions and billions of dollars every year in things like security, which you'll just never be able to for most organizations. Remember, value of data decays over time. Think about when that cross happens between the value and the risk of data. Look to retire data when that cross happens, and then look at leveraging AI capabilities and make sure you use the right model when you can. So that is all I have. And with that, I will answer any questions.
Thank you, George. And just as you are coming up with your questions here, and you can add them into the chat box, I'm just letting you know, everyone, again, that we will be sharing the presentation slide deck that George had here today, as well as the recording of today's session and the transcript. And if you have any questions, we have a survey in there as well, so you can give some feedback. And soon we'll also announce the session 2 and session 3. So keep an eye out on the website as well for that. Does anyone have any questions or anything? If not, I'll also make sure to add in George's details so you can find him on LinkedIn if you have any questions. Otherwise, you can always ask me. But I don't think there looks like to be any questions, Josh, but thank you so much for presenting today. We really look forward to session 2 as well. That will be the 15th of November, so we'll come out with the details very soon. Thank you everyone for attending. We really appreciate you all being here, and we really hope that you took away some great learnings from today. And please look out for that email coming through later today. And once again, thank you and have a great day.
Thank you.